All right, second half of ellipses. I hope you watched the first video on ellipses, so here's the second half. I will go over a couple of things that I covered on that video. If you haven't watched it yet, you might want to do that over the weekend, okay?
Okay.
All right, so this is the basic equation for an ellipse. X squared over a squared plus y squared over b squared equals 1. This is an ellipse centered at the origin, okay? And when you go to graph this, these, yeah?
Are ellipses spelled with 2 L's?
Yeah, aren't they? Yeah, no, it's 2.
Oh.
Yeah. Phew. Have I been spelling it wrong for 20 years? I hope not. I haven't taught this class for 20 years, 15. Okay, so we're going to go out in each direction a distance of A, left and right. The reason why you go left and right is because it's the number underneath X. And then you're going to go a distance of B up and down. And usually A and B aren't equal to each other, because if they are equal to each other, it's actually a circle. But, I mean, that's a special kind of an ellipse. But here's our ellipse. You go like this, and there it is. Okay, so let's talk about this a little bit. This, you know, the biggest axis is the major axis, and the smaller axis is the minor axis, and all that stuff. But then we also have those 2 nails in the board that I showed you, and those are called our foci. And the foci are always on the major axis, the longer axis, okay? And the foci are always a distance of, from the center, they are a distance of C. And so you have 2 foci equations. You have C squared equals A squared minus B squared. That would be for this one. And then if your ellipse was this way, up and down, then your foci equation would be B squared minus A squared. Okay? And you know, a lot of people are like, oh my goodness, it's so hard, there's so much to remember. Just remember it's the big one minus the small one. Big number minus small number, okay? All right, so I hope you guys were able to graph them, find all the parts to them. Now we're going to be given some information and we have to come up with the equation, okay? I've got like 5 of these to do, so here we go. Find the equation for the ellipse. Find the equation for the ellipse. And they're going to give you some information. And the information varies greatly. It's like they can give you this or this. You think, oh, that's not enough information, but it always will be. So let's say that they tell you that the vertices of the ellipse are at 0 plus or minus 7. And the co-vertices are at plus or minus 2, 0. Okay? And this is going to be the most basic, easy ellipse problem that you will have. Okay? The rest of them get a little harder from there. All right, so I hope you can do this one. Let's see. Here's what I tell people that kind of struggle with these. They get a little confused because it's a lot going on. Start with your basics. Your basics are this. You will always have an x squared. You're centered at the origin. Okay? You will always have a plus in the middle. And you will always have a y squared. And this always equals 1. Okay? That's kind of like the skeleton outline, right? Now we have to figure out what these numbers are underneath x squared and y squared. So underneath x squared is a squared, and underneath y squared is b squared. And a is the distance going this way, left and right, and b is the distance going up and down. So does anyone know what number would go underneath x squared? 2 squared. 2 squared. You got to be careful. So this is in the x spot, so it's going to go right here, 2 squared. And then over here, this one's over here on the y spot, so that would be 0 plus or minus 7, so it would be? 49. Perfect. And that would be the equation. X squared over 4 plus y squared over 49 equals 1. Okay? And if you had to graph that, you know, you'd go plus or minus 2 this way, plus or minus 7 that way, and you have your graph. Okay, so that's the easy one for the day. Now let's do some hard ones. Here we go, number 2. Like, oh, we feel so warm and fuzzy. Here it is. Let's say that the foci are going to be at plus or minus 7, 0. And the co-vertices are at 0 plus or minus 6. 0 plus or minus 6. All right, so anytime you have a problem that involves foci, you're going to use the foci equation. You're going to use c squared equals big number minus small number, and you have to decide. Well, in this case, the big number is going to be a squared because the foci are always on the longest axis, and that's in the x spot right now. So it's going to be a squared minus b squared. You will, at some point in this problem, use that equation. All right, so here we go. Set it up. If this is all you can do, and it's kind of sad, but if this is all you can do, do it. You know, do that. Yeah?
It said there were like two equations for the foci, so it was like c squared equals a squared minus b squared, and then switch.
Yes.
When do we use the switch?
The switch is, so this one is when a is bigger than b, and then this one, b squared minus a squared, will be when b is bigger than a.
Oh, okay.
So the first one is for parabolas that are longer going side to side, and the second one is for parabolas going longer that way.
Okay.
Yep. Okay, so now I have one of these answers already. I'm trying to get a squared and b squared, and I've got one of them. Which one do I have? Can you see? Yes! Good, I heard it. I have b squared already, because this is a covertice, which means it goes up and down a distance of 6, okay? It looks like this. Here's 6, here's -6. My foci are over here at 7 and -7. This ellipse would go past the foci like that. But I do know that that's 6. So I can go to my equation and write 36. Okay. So anytime they give you a vertices or covertices, you can plug that number in and square it and do that stuff. Okay. Now we got to find the foci. The foci, I'm going to use this equation that I said. C squared equals a squared minus b squared. C is the distance from the center to your foci. What is that distance? 7. See the foci? They're 7 away from the center. So that means c squared is 49. A squared is what I'm trying to find, minus b squared. Okay, these are already all squares. This is a squared, b squared, c squared would be c, which is 7, and you square it, it's 49. And then you solve for a squared. You add 36 over, and these numbers aren't going to be that pretty or nice, but that's okay. And what do you get? What is it, 85? So a squared is 85. Go up to here and simply put in 85 and you're done. That's it. Okay, not too bad. All right, I'm going to let you try one. Are you ready? Okay, get ready. Was that you, Preston? You said no? Don't you say no to me. All right, here we go. Let's go with foci are at 0 plus or minus 8. And your covertices are at plus or minus 4, 0. So x squared over something plus y squared over something equals 1. Now we have one of the somethings. I have a covertice at plus or minus 4, 0. So I'm going to put 16 right there. Okay? I hope you got at least that far. The rest of it's the hard part. Okay? So now I'm going to do c squared equals, and this time because the foci are in the y slot, then that means that it's going to be b squared minus a squared. Okay? All right. Yeah? Because the foci have to be on the longer side. So if you do struggle with these, drawing a picture helps a lot of people. So if I go 4 and -4, those are my covertices, and then I go 8 and -8 are my foci. That means that this ellipse goes past those numbers. So then it's b squared minus a squared. All right, so c squared is 64, because c is the distance from the center to my foci, which is 8. B squared is what I'm trying to find, and a squared is 16. And so then you solve, and b squared equals, what is that? 80? 80. Okay, and then go right back up here and plug in 80. Who got that? Oh, good, like 6 of you. You did not. You weren't even paying attention. All right, number 4. It's okay, you'll get the next one. You're not even paying it. I'm okay. All right, number 4. Here we go. Let's say that one of your foci, which is called a focus, is at the point 0, 3, And the y-intercept of a graph of the ellipse is 5. Okay, now you probably look at this problem and you think, that's not enough information. But it is. It's barely enough. Okay, so we want to find the equation of the ellipse. Okay, so here we go. Like I said, if you struggle on these, you can't visualize them very well, graph them, okay? One of your foci is at 0, 3. So go ahead and plot that and put an F for foci. Your y-intercept, you know what a y-intercept is? It's where your graph crosses the what? The y-axis, yeah. And your y-intercept is 5. Now what that means is your ellipse would look something like this. Okay? Doesn't have to be perfect, just something like that. All right, so here we go. X squared over something plus y squared over something equals 1. Good, you knew the one part. That's really good. Okay, so we have one of them. We need a squared and we need b squared. And we have one. Which one do we have? B squared, yes. B is 5. So 5 squared is 25, and that goes underneath the y squared. Okay, now we have to find the other one. Now I'm telling you, you guys, just remember, focus. See how it has the c in here? You're going to use that c equation every time. So c squared equals big number minus smaller number. It's bigger going this way than it is that way, up and down. So let's go ahead and find out what these numbers are. So c, remember, is the distance from the center to the focus. How far is that? From the focus? It's 3. Yeah? So 3 squared is 9. B squared is 25, and A squared is what I'm looking for. Now, you might be a little alarmed, thinking, oh no, we're going to get a negative, but we won't. Subtract 25, and you get negative 16 equals negative A squared. Yes, divide by negative 1. A squared is 16, and you're done. That's it. I know, Wyatt. No, you don't need to clap. It's okay. All right, number 5. You did? That was a good one. All right, last one of the day. The focus is at negative 5, 0. The width is 14. I mean, it's Friday. I'm getting ready to go to the club. The Sam's Club. Have I said that before? Yeah. My jokes are old. X squared over something plus y squared over something equals 1. Okay, here we go. Once again, if you want to draw a picture, go ahead. You can. It might help you. So the focus, one of our foci is at negative 5, 0. And the width is how long? Going this way. Width, height, and width. Okay, so the width is 14. So how far would I go in each direction? 7. Very good. So that's what my ellipse would look like, something like that. Okay, so let's go ahead and get these numbers filled in here and here. So one of them I know already. What is it and where does it go?
Under the x squared.
Oh, wait, nope. It goes out this far to 7. Yeah, so 49 underneath the x squared. Okay, and then c is 5, the distance. 25 equals, yes? Good. Oh, the width is 14. So if something has a width of 14 and it's symmetric, it's going to be 7 and 7. Yeah. And then subtract 49. 24. Perfect. You got it. Then go up here and plug in 24. And that's it.